All right, let's take a quick 5-minute tour through the incredible piece of engineering that is your arm. I mean, think about it. Every single thing you do, from waving hello to typing an email, starts with this complex chain of command that runs all the way from your shoulder to your fingertips. So we're going to trace that path and see how it all works together. Just by holding your phone right now, you're putting this whole system to work. It's pretty amazing when you think about it. We're going to break down the key players, the muscles, the nerves, the arteries that make it all happen. And we're going to start at the very top. So our journey kicks off right here at the shoulder. This is one of the most mobile, most incredible joints in your entire body. It's held stable by a super important group of muscles called the rotator cuff. But here's the thing. Each one of those muscles has a very, very specific job to do. So let's start with a key movement. Picture this. You're rotating your arm outward, away from your body, kind of like you're winding up to throw a baseball. Which muscle is the main one responsible for that specific action? And the answer? It's the teres minor. Now, it might not be the most famous muscle in your shoulder, but it is absolutely essential for that external rotation. It's a perfect example of how these small, specific muscles create really powerful, precise movements. If this little guy gets injured, even simple things like reaching into your back pocket can become almost impossible. And this is where you can really see that beautiful division of labor in the shoulder. While our teres minor is busy rotating the arm outward, you've got the latissimus dorsi, pectoralis major, and subscapularis all working together to rotate it inward. And the supraspinatus? Its main gig is just getting your arm to start lifting out to the side. They all have to work in perfect, beautiful harmony. Okay, so from the shoulder, let's travel down the arm into the forearm. This section is all about two things, power and flow. We're talking about the muscles that actually turn your hand and the arteries that keep them fueled up and ready to go. Okay, try this with me right now. Hold your arm out and turn your palm so it's facing up towards the ceiling. That movement is called supination. An easy way to remember it is you could hold a bowl of soup in your hand. So which muscle is the main driver of that action? And the answer might actually surprise you. It's the biceps brachii. Yeah, we all know the biceps for making a muscle and flexing the elbow, but it turns out it's also the most powerful supinator of the forearm. It's a real 2-for-1 powerhouse. This is just a perfect illustration of how opposing muscles work. While your biceps is handling supination, turning that palm up, the pronator teres muscle does the exact opposite. That's pronation, or turning your palm down. You can literally feel those different muscles engaging as you switch back and forth. It's this incredible balance of forces that gives us such fine control. Okay, so we've got these powerful muscles doing all this work. But just like any engine, they can't run on empty. They need a fuel line. And that, of course, is where the circulatory system comes into play. The forearm is neatly divided into different compartments. So which major artery is responsible for feeding the muscles in the back or posterior part of your forearm? We're talking about the ones that lift your wrist and fingers up. That would be the radial artery. Hey, if you've ever checked your pulse on your wrist, right on the thumb side, you were feeling the radial artery. Go ahead, find it right now. That's the critical lifeline for all those muscles that let you extend your wrist and fingers. The blood supply in the arm is just so organized. It's like a highway system with different exits. The subclavian artery starts the whole journey. It becomes the axillary artery in your armpit, and then the brachial artery in your upper arm. Then, that brachial highway splits into two main roads, the radial and ulnar arteries, which feed different parts of the forearm. It's an incredibly efficient distribution network. From the forearm, we arrive at the wrist. And here, we find one of the most famous, or maybe infamous, structures in the arm, the carpal tunnel. Now, a lot of people have heard of carpal tunnel syndrome, but what exactly is the carpal tunnel? Well, think of it as a really narrow expressway with some very, very important traffic trying to get through. So you have all these vital structures trying to navigate the tight space of the wrist to get to the hand. Which one of these is the critical passenger that has to travel through the carpal tunnel itself? The answer to this is the whole key to understanding why carpal tunnel syndrome even happens. And there it is, the median nerve. It's squeezed into this tiny passage along with 9 flexor tendons. And that's the whole issue. When you get swelling in that tunnel, maybe from repetitive motions, that nerve gets compressed. It gets squished. And that's what leads to the pain, the numbness, and the tingling of carpal tunnel syndrome. It's a classic case of high traffic real estate. What's so interesting is that the other nerves and arteries take totally different routes to avoid that traffic jam. The ulnar nerve, for example, it bypasses the carpal tunnel completely and goes through its own little private passage called Guyon's Canal. This anatomical map is exactly why symptoms in your pinky finger, for instance, tell a doctor it's probably not a carpal tunnel issue. All right, so our median nerve has successfully navigated that carpal tunnel expressway. But its journey isn't over yet. Nope, it has a final, crucial destination, what I like to call the command center for our thumb. The phanar muscles are that fleshy group of muscles right at the base of your thumb. You can see them bulge if you touch your thumb to your pinky finger. They're what make our thumbs so mobile and opposable. So, having just passed through the carpal tunnel, which nerve do you think is in charge of controlling them? Yep, you guessed it, it's the median nerve again. This is the big payoff for its whole journey. It provides the electrical signal, the power, to those thenar muscles. This gives us the ability to pinch, to grasp, to do all the fine motor tasks that make our hands so unique, from writing with a pen to scrolling on a smartphone. And look at that. Once again, we see this incredible division of labor. It's all about teamwork. While the median nerve is handling the thumb muscles, the ulnar nerve is taking care of most of the other little muscles deep inside the hand, and the radial nerve is managing all the extensors on the back of your hand. Each nerve has its own distinct territory and its own job to do. So, let's just zoom out for a second and put it all together. From the teres minor rotating your shoulder, to the biceps turning your palm up, to the radial artery fueling those muscles, all the way to the median nerve traveling through the carpal tunnel to command your thumb, it is all one seamless, perfectly interconnected system. Every single part we've looked at has a specific, vital role to play. Your arm truly is a masterpiece of biological engineering, capable of both incredible power and the most delicate precision. So, the real question is, what will you build with it?